Okay, so in this video, we're going to be looking at trig ratios for angles between 0 to 360 degrees. So up until now, we've been really looking at acute angles, so less than 90 degrees. Now we're going to be looking at angles bigger than 90 degrees. So the main difference is that all the triangle angles we've been looking for, if this is 90 degrees, this is 180 degrees, this is 270 degrees, technically this is 0 and also kind of like 360. But yeah, that would be a full circle. Basically, when we have an angle, or in our videos, our past couple videos, when we've been doing trig ratios, we've been looking at angles really over here in quadrant 1, and this is quadrant 2, quadrant 3, quadrant 4. Here we have 0 to 90 degrees. Here we have 90 to 180. Here we have 180 to 270. Here we have 270 to 360. So this is going to be very important for us. Up until now, we've been doing our sine, cos, and tan ratios in quadrant 1 with 0 to 90 degrees. But now we're going to be looking at problems that are going to go into quadrant 2, 3, and 4. And one thing to remember is this. The cast, C-A-S-T. Remember quadrant 1, 2, 3, 4. Cast, C-A-S-T. Yeah. If I remember that correctly. No, wait, I messed this up. It should be C-A-S-T. That is correct. Ignore this. So, remember this cast. All this basically means is, in quadrant 1, when we have A, that means sine, cos, and tan. When we do any of these operations on the angle, we're going to have a positive output. So it's going to be a positive number when we do the inverse sine or inverse cos or inverse tan. In quadrant 2 we have an S, so here only sine will be positive. The other two will be negative in this quadrant. Similarly, in quadrant 3, only tan will be positive. Sine and cos will be negative in quadrant 3. And in quadrant 4, we have cos, that'll be positive. And sine and tan will be negative in this quadrant. So these are just some things to remember as we start looking into these things. Let's start with maybe an example. We can do quadrant 1. Let's say we have a point on a graph 3, 4. That is my line. So I know from this triangle and this theta, this is basically the triangle I'm going to make 3, 4, and I know from Pythagoras' theorem 3 squared plus 4 squared is 25. Square root of that is 5. And then I have an angle. So now I can find this angle to the nearest degree. We can do any sine, cos, or tan. If I write out the trig ratios, sine theta is opposite over hypotenuse, which is 4 over 5. Cos theta is equal to adjacent over hypotenuse. Tan is opposite over adjacent, which is 4 over 3. one of these into the calculator, and your theta will give you 53 degrees. And notice how these are all positive ratios because we are in quadrant 1. But let's say instead of in this quadrant, I want to choose it in this quadrant over here. I choose to do -3. And the same y value. Now I want to find out this angle. Now let's try doing the exact same thing. Well, for one, our Pythagoras theorem will give us this to be the same because we're squaring it. Doesn't matter if it's -3 squared plus 4 squared. This is still going to be positive, so that's 9 plus 16. Right? So, if we were to write these trig ratios out again, now we have this 4, 5, but -3 here. It's in the negative, on the negative x-axis. And I'm looking for this angle, so if I was to write these again, sine is equal to opposite 4 over 5. Cos theta is equal to adjacent -3 over hypotenuse 5. Tan theta is equal to opposite over adjacent over -3, so that's a negative. Now you see why from our CAS system, S in quadrant 2 is the only one that is positive. The other two are negative ratios because they're in this quadrant. And you'll see that once we go into tan, if we do the same, well again, if you were to do these inverse of these, you should get the same. Theta equals 53 degrees. Let's do another one. Now let's go into the next quadrant. If we were to go into quadrant 3, like down here, -4, -3. Let's go like this, -4, -3. This is still going to be a positive hypotenuse. So, now, if you were to write for these angles, if you were to write these out, you would get sine opposite over hypotenuse, -4 over 5. Cos theta is equal to adjacent over hypotenuse. Surprisingly, tan opposite over adjacent, -4 over -3. The negatives will cancel out and you're left with 4 over 3. And that's why your tan is positive in quadrant 3. And now let's do the last one. -3, no, this is +3 and -4. That's the point. Angle, we still have 5. If you were to write these out, sine theta is equal to opposite -4 over +3. Sorry, hypotenuse 5. Cos theta is equal to adjacent 3 over 5. Tan theta is equal to opposite over adjacent -4 over 3. And again, you'll see cos is positive in quadrant 4, tan is positive in quadrant 3. And that's basically what it is. So, another thing that I didn't do though is explain to you the angles when it's in different quadrants. So, if you were to solve for all these thetas, you would get 53 degrees. But 53 degrees only makes sense in this one. Like this right here. But over here, we have to take the angle starting from this line here. So from here to here is what? If this angle is the same as that angle, then we have to do 180, which is this line here, a full 180 minus theta, which is the one that we found. 180 minus 53 is 127 degrees in there. And then similarly, we have to do the same for quadrant 3, which is here. And that is from here all the way. Like that. So now we have 180 plus 53. And that will give us 233. And then we have our final quadrant, which is going to be here. And this is much easier. We just do from here all the way around. A full circle would be 360. We're going to do 53 less than 360. And we're left with 307 degrees. So there you have it. We have 53 degrees, 127, 233, 307. That is how the cast system works. And this is going to come in handy for us when we start using logic to come up with where the angle is. So if I was to tell you that, for example, CSC theta is equal to negative 2 root 3 over 3, and I was asking you where is this? So by logic, you can just do, this is 1 over sine, so just take the reciprocal of that. So sine theta is equal to negative 3 over 2 root 3. And if you have a negative sign, that means it cannot be in quadrant 1 because everything is positive in quadrant 1. It cannot be in quadrant 2 because sine is positive there. It has to be either in 2 or 3. And that's where, and in quadrant 2 and 3, that's where theta is, the angle. When we solve for theta equals, if you put the inverse of this into a calculator, you should get, let me try punching this in. 2 times root 3 over answer times negative 1 inverse sine. Oh, I get negative 60. So yeah, I get a negative 60. So that means my negative sign in my negative sign ratio, which we have said is going to be in quadrant 2 or 3, I have 180 plus 60 or 360 minus 60. So now I have either 240 or 300. These are my two solutions. And that's how we're going to be solving trig ratios moving forward using the cast system here, because this is going to be very important to understand and understand why certain things are positive or negative in each quadrant because of how the ratios apply. So that's all for this video. It's just an intro to the cast system. And shall see.